All right, for these notes, we are going to continue on looking at volume. These are just application problems, so we're not using any new formulas. We're not learning anything really that's new. We're just looking at new scenarios. So instead of them giving you a picture that is labeled, although there could be pictures that are labeled, they're giving you a problem that feels a little bit more story-like. So the problems could be as simple as example one says Betsy receives a flower in a vase that's shaped like a rectangular pyramid and wants to know the volume of the vase. She measures the height, the length, and the width of the vase. The vase measures 12 inches tall, 3 inches long, and 4 inches wide. What is the volume of the vase? So that one's pretty straightforward. It almost won't even feel like a story problem when you do it. So first we're going to find the area of the base. And the area of the base is 3 inches by 2 inches, which is 6 inches. And then the volume, since this is a rectangular pyramid, the volume is 1/3 times the area of the base times the height. And so I'm just going to type that into my calculator. 1/3 times 6 times 12. That's 24 inches cubed. So the problem could be very straightforward like that, okay? Example 2 shows how the problems could make you think a little bit more. So here it says at the store, Jason finds the total volume of soda in a pack is 381.51 cubic inches. If each cylinder-shaped can has a height of 6 inches and a diameter of 3 inches, I'm going to write radius equals 1.5. How many soda cans are in a pack? Use pi equals 3.14. So I'm going to go ahead and find the volume of one can. So the area of the base of a can is going to be pi times r squared. So 1.5 squared is 2.25. And then the volume is going to be 2.25 pi multiplied by the height of the can, which was 6. So 2.25 times 6 is 13.5 pi. And so to be able to figure out how many cans are in that pack, we can do the total volume divided by the volume of a single can. So the total volume divided by the volume of a single can is going to tell us the number of cans. So we're going to do 381.51 divided by 13.5 pi. And they told us to use 3.14 instead of pi. So I'm going to do 381.51 divided by 13.5 times 3.14. And I get 9 cans. 9 cans in a pack. So this problem would have required a little bit more thought because it's not just as simple as finding one volume. You have to do a little bit more there. All right, let's go ahead and do one more problem. I'll leave example 4 for in class. Gobs of Globes is a specialty store which carries a variety of globe-related products. One of their popular products is a globe piggy bank. The standard one they carry has a volume of 500 pi thirds cubic inches. A customer asked for a custom-made version with a radius quadruple the size of the standard one. Based on this information, what will be the radius of the custom-made version? So globes are spheres. That's kind of a circular shape. And so when we say volume, we're going to use the formula 4/3 pi r cubed. So we're going to set those volumes equal to each other. 500 pi thirds, I'm going to kind of make that fraction not go all the way across. I'm going to go ahead and just get rid of my pi's first. So I have 500 thirds equals 4 thirds r cubed. I'm going to go ahead first and just multiply each side by 3 just to get rid of that 3 on the bottom of the fraction. So now I have 500 equals 4r cubed. I can go ahead and divide by 4. 125 equals r cubed. Now to get r alone, I can go ahead and cube root it. So I get 5 equals r. So the radius of the original globe, piggy bank, was a radius of 5. They want to quadruple that, which means they want to multiply it by 4. So the original piggy bank, the units on this, let's see, cubic inches. The units on this were inches to start with. So the original globe had a radius of 5 inches. So they want the new globe to have a radius of 20 inches. That's huge. That's going to be a very large globe, piggy bank. So 20 inches are what the new radius should be. All right. Do not do example 4. Save that. We're going to do that one in class.